In the previous homework exercises in Chapter 6, we saw how ions, that is, atoms that have charges, are formed. But what happens to them after they're formed? That's what exercises 8 and 9 are trying to talk about. So you can have two types of ions. Remember that an ion is an atom that has a charge, but you can have two types. You could have a positive ion. That's called a cation. Or you could have a negative ion. So a negative ion, that would be called an anion. So you could have a cation with a positive charge or an anion with a negative charge. Those are the two types of ions. You can remember those because the T in cation sort of looks like the plus sign. Okay, now that's what happens after you form the ions. You get either a positive charge or a negative charge, but opposite charges attract. So when a positive ion, when a cation goes into the world, it starts sticking to anions because cations have a positive charge, anions have a negative charge, and opposite charges attract. Okay, but what ratio do they combine in? So the ions, combine until the overall charge is 0. So let's think about this first case. Exercise 8, part A. Imagine you had sodium with a +1 charge. Okay, and if no number is written, like is the case up here, it just means it's a 1. Okay, and then let's say you have an oxygen with a -2 charge. Now, if just one sodium ion came together with one oxygen ion, you would have NaO, and what would the overall charge be? It would be +1 -2, so it would ultimately be -1, and this whole thing would have a -1 charge. Okay, so that would happen if you brought just one of each together, but that's still sticky. These charges are really telling you how sticky an atom or a group of atoms is. So if there's more sodium, and there would be, remember we live on an enormous scale compared to atoms. Every time you exhale, you breathe out more atoms than there are stars in our galaxy. So if there's enough sodium, if there's any sodium somewhere for us, that means there's a lot of sodium. So another sodium atom could come along, and the positive charge here would be attracted to the negative charge on that big clump of stuff. So now you would have two sodiums, so it'd be like Na, and O. What's the charge on this? Well, you would take the +1 here, and then the -1 here, and you'd see that the overall charge would be 0 here. Now, there's another thing to note about this. You have two sodiums repeating. Instead of writing the symbols twice, what people do is they write the number 2 in the bottom right of the symbol. So this 2 here means you have 2 sodiums. And then the oxygen there. So don't confuse the number at the bottom right, which tells you how many of that atom you have in a compound, with the numbers in the top right, which tell you the charge. Okay, so what did we just see? We saw how ions come together until the overall charge is 0. Now notice there's a pattern here. We wouldn't have to go through this big, long explanation every single time that we try to figure out how two ions come together. There's a pattern. Whatever number is at the top of one ion goes to the bottom of the other. So here, because nothing is written, it means there's a 1. Whatever is at the top of one ion goes to the bottom of the other. And so that's where this 2 is coming from. Notice you don't bring down the plus or minus signs, because the numbers at the bottom aren't charges. So the shortcut is, if you ever have two ions, just crisscross them. So that the number at the top of one goes at the bottom right of the other when they come together to form a compound. And that will make sure that the charges add up to 0, so that the molecule is not sticky anymore. So this here would be the correct ionic formula for the compound form between Na plus and O2 minus. Okay, so that's the long explanation. Let's try just doing the shortcut. You'll see that this is really straightforward and simple. The positive charge has the 3 plus, right? 3 plus there. The anion has a minus, and that's a -1 because no number is written. And so to predict what the product will be, the number at the top of one is going to go at the bottom right of the other in our answer. So we'll have Al with really a 1 there. Notice how I don't include the negative sign. But also, when you just have one, you don't have to write the number, because by writing Al, I know I have one of them. Okay? And then the 3 at the top of aluminum will go at the bottom of bromine. So you'd have Br, and then notice how the plus sign doesn't go down, just the number. So this would be the compound that you would form if you mixed these two ions. You would need 3 of these negatively charged bromines to balance out the positive charge on the aluminum. And the number that says I need 3 of these is the number at the bottom right. Okay, so let's say we have barium, and that has a 2 plus charge. And then we have nitrogen, and that has a 3 minus charge. These are going to attract each other because they have opposite charges, and they'll attract each other until the overall ratio is 0. How many of each atom will we have when the overall charge is 0? Crisscross the charges, so the number at the top right of one goes at the bottom right of the other. So the number at the top right of one goes at the bottom right of the other. And you could see that if you had 3 bariums, that would be 3, each one has +2, so that's +6. If you had 2 nitrogens, each one has -3, so 2 of them -6, and altogether, that would be 0. So we're crisscrossing the charges so that the subscripts tell us how many of each atom we need in order for the overall charge to be 0. And so that would be the symbol, the correct ionic formula for the compound that barium forms with nitrogen. All right, let's try the compound between magnesium and fluorine. So we'll have magnesium, and magnesium has a 2 plus charge. Fluorine has a 1 minus. And because no number is written there, we know that the number must be a 1. So you crisscross the charges. At the bottom of magnesium, at the bottom right of magnesium goes the same number as what was at the top right of fluorine. So that'll just be a 1. But you never write the 1. By writing Mg, you know you have one of them. And then the 2 at the top right of magnesium will go at the bottom right of fluorine. So 1 magnesium would stick to 2 fluorine atoms, and that would make a new compound. All that together would have a 0 charge, so it would stop being sticky. And other atoms wouldn't stick to it. Okay, so we have aluminum 3 plus, and we want to know what ratio is that going to stick together with sulfur. Sulfur has a 2 minus charge. So you can crisscross the charges. The 2 at the top of sulfur will go at the bottom of aluminum. So aluminum, and then the 2 there. Notice I'm not bringing down the minus sign, just the number. And then the 3 at the top of aluminum can go at the bottom of sulfur. So we have sulfur, and notice I'm not bringing down the plus sign, just the number. And so that ratio of aluminum to sulfur atoms would give you a charge that's overall 0. And so those would be the correct ionic formulas for the compounds formed between those ions. That's exercise 8, and exercise 9 is essentially the same thing. So I'm going to write the ions again. Aluminum has a 3 plus here, and chlorine has a 1 minus. And so to get the subscripts, you just crisscross the charges. So first, that 1 goes at the bottom of aluminum, but you don't have to write the 1 because by writing Al, you know you have one of them. And then the 3 at the top of aluminum will go at the bottom of chlorine to tell us that we need 3 chlorines. Remember, the numbers at the top are charges. They tell you how sticky an atom is. The numbers at the bottom right tell you how many of that atom there are in a compound of a bunch of stuff sticking together. So for every 1 aluminum, you would need 3 chlorines in order for that to have a 0 charge. How about for B? So for B, I'm going to write each of these, and I'll just write them twice. Okay, so we've got calcium has a 2 plus charge, and sulfur has a 2 minus charge. Now this is an interesting scenario. Remember, our goal is just to get the overall charge to be 0. If the charge is ever the same amount, so 2 plus and 2 minus, if it's ever the same amount on both, then it's a 1-to-1 ratio, and you can just write the symbols together without writing the charges. Because 1 calcium, which has a 2 plus charge, will cancel out with 1 sulfur, which has a 2 minus charge, and the overall charge will be 0. So that's one case where you wouldn't have to crisscross them if the numbers are ever the same in the top right of both of the ions. Okay, how about lithium and sulfur? So lithium has a +1 charge, and if no number is written, it's a 1. Sulfur has a 2 minus charge. And so how do these combine? The 2 at the top right of sulfur goes to the bottom right of lithium. And then the 1 at the top right of lithium goes to the bottom right of sulfur. But you don't have to write the number 1, because by writing the sulfur, you know you have at least 1 sulfur atom. And so that is the ratio that lithium and sulfur combine together in order to get an overall charge of 0. 2 lithiums to 1 sulfur. Okay, how about rubidium and phosphorus? So rubidium has a +1 charge, and because no number is written, we know it's a 1. Phosphorus has a 3 minus charge. So what compound do they form? Take the number at the top right of phosphorus and bring it to the bottom right of rubidium. So rubidium will have a 3 there. Notice I'm not bringing down the negative sign. And then take the number at the top right of rubidium and bring it down to the bottom right of phosphorus. Because it's a 1, I don't have to write it. By writing a capital P, I know I have at least 1 phosphorus. And so that's the ratio that rubidium and phosphorus would combine in. You would have 3 rubidiums sticking to 1 phosphorus. And that would give you an overall charge of 0, so that the compound wouldn't be sticky anymore. It wouldn't react with anything else. Okay, cesium and iodine. So if we take cesium, and cesium here has a +1 charge, and then iodine we can see has a -1 charge. And I know those are both 1 because no number is written. This was a case kind of like we saw before. If the charge is ever the same on the 2 ions, if the amount of charge is ever the same, +1, -1, they're both 1, then you can just rewrite the ions without their charges. So Cs and I. This would be the compound that those 2 ions would form. You'd have 1 cesium atom for every 1 iodine atom to give you an overall charge of 0. So what you would want to take away from this is that you can find the ratio that 2 ions combine in by crisscrossing the charges in the top right of each ion to make them go to the bottom right of the other element.